Okay, so for this semester of robot soccer competition, we had 7 teams, about 5 people per team, and we were in charge of generating computer vision algorithms, motion control algorithms, as well as physically designing our robots. So really, teamwork was pretty essential. Just to give you guys an example, here are 4 of the team's robots that we competed against. One of our standards was that each robot had to fit within a 10-inch high by 8-inch diameter cylinder. So other than that stipulation, teams could design robots however they wished. Some teams, they went with a symmetric design, some went round with kickers, some preferred a larger kicking face. But really, we had the freedom to do whatever design we wished. For us, we decided to go with a pretty standard hexagonal design as well, just because it gave us the most volume internally to work with. We also decided to include a kicker, and we based our inner body on aluminum plates, so it is really durable. As far as computer vision goes, this was the field that we were playing on. It's a little bit disassembled now, but it's about 10 feet by 5 feet. And we used a yellow ball, and it was a 1 versus 1 competition. So here, we had an IP camera overhead that could see the whole field. It was a little higher in the ceiling than it is now. But this allowed us to see the whole field and allow all of these different teams on the different workstations to connect to the same camera, receive the same image, so no one had a competitive advantage just off the image alone. On each workstation computer is where the computer vision algorithms are run. So I'll start ours up right now. We were running Linux on these machines, and we did our computer vision algorithm using C++ and OpenCV. So when it first loads, you can see that it allows the user to calibrate the dimensions of the field as well as center the field. In our case, for this demonstration, I'll just select the field as this size. We then are able to color threshold the ball. It shows the user the original image as well as the thresholded image, which can be adjusted using these HSV, hue, saturation, and values, so that the ball can be isolated. We then calculate the ball's position based on the area of the thresholded objects. We do the same procedure for the robots, where the larger object we call the rear, and the midpoint, as you can see on this image, is the midpoint between these 2 objects. After we calibrate the colors for each robot, it shows us a final image of the field dimensions that we selected, as well as the robots, their X-Y positions on this coordinate frame, as well as their angles. With this data, we have a motion control and AI program here that allows us to verify that the robot is receiving the correct data that we're sending it. From this command center, we can send the robot commands. For example, I can tell the robot, our robot's in blue, I can tell it to go to the center, and it will move itself to the center. Or I can tell it to go to a starting position, and it will move itself to the starting position. With the ball on the field, we can also have it autonomously score the ball. So for example, if I tell it to score the ball, it will line itself behind and kick the ball towards the goal. This play allowed us to place first in our BYU competition this year against 7 teams. We were undefeated, and we're looking forward to see how next year can build upon our platform.